Okay, hello guys, what is up? Okay, welcome back to our September week 3. Okay, so today we are going to a new chapter, guys. We are going into a new chapter, which is chapter 8. Okay, we have finished chapter 7, the drugs one we have already done. So today we are going to chapter 8. Right, so chapter 8, we will be learning about matter. Okay, not the medicine yet, that's chapter 9, I think. Okay, so we are learning about chapter 8. For this chapter, right, it's quite easy because you already learned this, the front part anyway, you already learned this in Form 1. Form 1. Okay, so we come back to this atom thing again lah. I'm sure you learned this in Form 1 already. As you know, atom has proton, neutron, electron. I'm sure you already know that. Okay, so anyway, let's go to this thing called particles. All right, so in Form 2, right? Oh, sorry, in Form 1, right? You learn that particles has two, right? Okay, if you still remember. So we have two types of atom. Here's two types of particles here. Hang on. Shaina, hello. Good evening. We are in chapter 8. We're in chapter 8. So we learned this last time in Form 1. So you know what is an atom, right? You know what is a molecule, right? You already learned this before. So let me go into this again. Atom is the smallest thing in the world. Okay. Yes, Gabriel, hello. Atom is the smallest thing in the world. It's the simplest thing in the world. If the world is made up of Lego, the smallest piece of Lego is atom. You cannot take this any further. You cannot take this apart any further. That's the smallest you can get. That's your atom. All right, so easy stuff lah. You learn this in Form 1, Form 1 already. So it's the most basic unit in any element. All right, so when you put two atoms together and above, when you have two or more atoms, we call it a molecule. Two or more atoms which are chemically combined, they become friends. Okay, like this, you see, they become friends. They become friends. They are joined towards each other. So that is your compound, if you remember. Compound. The not combined one is called mixture. Okay, that's your Form 1. Right, so this is a molecule. So molecules can be the combination of same or different types of atom. They can be the same or they can be different. So that's your molecule. Right, so guys, I want to put it this way lah. Many atoms, they are called molecules. It's just like alphabets. Okay, alphabets. When you have few alphabets put together, you will get a word. Right? When you have a few alphabets put together, you have a word. So it's the same. When you have a few atoms put together, you have a molecule. Okay, so it's the same thing. And of course, we have the third one. This one you didn't learn it in Form 1. Now that's an extra one. Okay, that's an extra one. This is what we call an ion. Okay, an ion. So what is the ion? Ion is a charged particle. What does it mean? That means they have positive or negative charge. They have charge. Then we call it an ion. Okay, ion, sorry, not ion, ion. Okay, we pronounce this as ion. Okay, so easy, huh? We have one more extra here. Okay, so anyway, let's look at the substances. Let's look at the substances. All right, if I say a substance is only made from atom, we call it an atomic substance. Right? For example, a gold bar. Okay, a gold bar. All right, so a gold bar is an atomic substance. You know what's a gold bar? Okay, you know what's a gold bar? This is a gold bar. Okay, this is a gold bar, right? So a gold bar is an atomic substance because it is only made up of one type of atom, which is the gold atom. A gold bar inside only has gold atom because they are 99.999% pure. There's only gold atom inside. Maybe a few atoms of oxygen, maybe, but they are generally very pure. Okay, so that's what we call an atomic substance. So you see, all metals are atomic substance. All metals. So if you remember what is this? If you remember what is this, that's right, that is your periodic table. So all these metals here, all these metals, they are atomic substance because they are only made from one type of atom. I'm talking about a pure metal, of course. Of course, metal, we have impure and pure. I'm talking about pure metals. All right. And of course, there's a very special gas here. All right, guys, 99% of gas, they are not atomic. Besides these gases, what we call inert gases. If you still remember what is this, you learned this in Form 1 actually. The last group of a gas of the periodic table is what we call inert gases. All right. Why do we call it that? Why do we call it inert gas? Why do we call it inert gases? Because they are very unreactive. Inert means unreactive. They won't react with anyone. They are just chill. Okay. They won't react with anyone. They are just, they just mind their own business. Okay. They won't react with anyone. That's the thing. All right. So that's your inert gases. Okay, that's your inert gases. So they are atoms. They are atoms. As you can see, they are single. They are like single and alone. So that's an inert gas. Okay, because they are stable. What? When you are stable, when you are happy by yourself, do you need to marry someone to get happy? No, you don't. You just kind of chill alone. So that's a very rare types of gas. All right. So when we talk about atomic substance, mostly we refer to metals because most metal they are atoms. Okay. So anyway, let's look at an example, shall we? Let's look at the state example first. Okay, like iron. An iron bar, like just like I say gold bar, right? An iron bar is the same thing. Iron bar is only made from iron atom. As you can see, there's only one type of atom here. So this is an atomic substance. Guys, this is very important, guys. This part is definitely coming out in exam. So this is your atomic substance. So about their state, most atomic substance, they are solid because they are metal. All metals are solid, right? All metals are solid, right? And then they, except for mercury, mercury is the only liquid in this case. Okay. Yes, Neha, hello, good evening. We are in chapter 8. All right, so so mercury is the only liquid. Guys, all metals, they are solid besides one metal, that is mercury. Mercury is the only metal that is liquid in room temperature. That's why they can be put in your thermometer. Right? And then next, of course, your inert gases, like I said, most inert gases, as the name say, they are gases. So these are all gases, right? Anyway, so these are your atoms. So let me repeat this again. If something is only made from atom, that is your atomic substances. In this case, you have metals. Like I said, gold bar. Gold bar is only made from gold atom, one type of atom. Okay, iron bar. Any bar, any metal bar, okay, aluminium bar, zinc bar, copper bar, silver bar, gold bar, platinum bar, all kinds of metal bars, they are all made from atomic substance. They are all atomic substance because they only have atoms. Okay, so mostly we refer them as metal. Right, next, what about molecules? Okay, if you put two atoms together, you will get molecule. Right, all molecular substance, they are non-metal. Mostly like 99% they are non-metal. Like for example, what is a molecule? Oxygen is a molecule because they have two oxygen atoms together. So are they a metal? No. You're breathing this in. How can you breathe metal? And of course, water. Water is H2O. We have one O and two H. So is this metal? No. No, you have 3 atoms here, but they are not metals. So this is all non-metal, right? So about the state, they can be solid, liquid, or gas. Okay, like water is liquid lah. So oxygen is gas lah. Right? Solid, that will be your naphthalene. Guys, do you know what is naphthalene? Do you know what is naphthalene? Naphthalene, we also call it mothball. Do you know what is this? Just by looking at it, I bet you can smell it already. Ugh. Okay, when you have this thing in your cupboard, oh my god, you will know. Yes, okay, you will know. Okay, that smell, goodness me. Okay, so what is this thing for? It's to chase away insect. Okay, as the name says, it's to chase away moth. Because moth, if you keep certain dress in your closet, and you don't wear them very often, okay, you don't wear them very often, moth will go there and lay eggs on it, and they will just kind of ruin your dress. So they just put this in, so they just chase the moth away. Not only they chase moth away, they will also chase cockroach away. They will chase anything away. They will chase human away. Goodness me, this is so smelly. Okay, so that's your mothball. So that's your naphthalene. So they are a solid. Okay, they are a solid, and of course they are a non-metal. Well, obviously, this doesn't look like metal to me. So atom is mostly metal, molecule is mostly non-metal. Then the next one, we have the third one we call ion. Guys, ion is the reaction between metal and non-metal. When you have metal from atom and non-metal from molecule react together, you will get an ion. Okay, you get an ion. Like for example, you know what is sodium chloride? You know what is sodium chloride? Sodium chloride is just another fancy name for salt. All right, so sodium chloride is made from sodium ion, which is a metal, and they are also made from chloride ion, which is a non-metal. So this metal and this non-metal, they react together, they will become salt. And funny enough, sodium is positive, chloride is negative. Why? No, why? That's the way it is. Okay, usually metal is the guy. Okay, imagine positive is guy, negative is girl. I just remember it that way. So metal is usually guy because guys are hard, and then girls are soft. So non-metal is negative. Usually it's that way lah. So they are all solid. They are all solid. For example, sodium chloride. For example, iron oxide. So when you have iron, which is a metal, marrying oxygen, which is a non-metal, they will become iron oxide. So what is iron oxide? What is iron oxide? Guys, if you don't paint your iron, when your iron reacts with oxygen, what do you get? What do you get? If you don't paint your gate, if you don't paint whatever iron that's exposed, so what do you get? It will turn into this brown color stuff we call rust. Right? So iron oxide is just another fancy name for rust. Okay, it's oxidized iron because the iron reacts with oxygen, so it's oxidized. Okay, there. So this is an iron. Ion. All right, so let me wrap this up. Atom is mostly metal. Besides inert gas, this is very rare. Molecule is mostly metal. Ion is mostly metal plus non-metal. All right, there you go. So it's not really that difficult. I'm sure you already know this lah. Inside an atom, you have electron, which is negative, proton, which is positive, neutron, which is no charge. You learned this in Form 1. For the love of God, please don't tell me you don't know what is this, unforgivable. Right, so same elements can exist in different form. Like you see, atom in an iron atom, they are metal, right? They are metal, right? So you have a new iron hammer. Like iron is when they kawin with a non-metal already, they will become rust. Okay, hydrogen, the same thing. Hydrogen molecule, they are like the non-metal in air. when they okay, you know what? I'm gonna skip this. This is not your matter. Okay. Anyway, so I hope you understand this. What is atom? What is molecule? What is ion? They love asking this in exam. Love it. So which makes it a good thing because it's really easy, isn't it? Okay, so this matter part is really easy. All right, so moving on. Let's go to our periodic table 8.2. Right, I'm going to talk a little bit about this today. All right, so what is periodic table? As you see, all the types of atoms. So okay, like I said, right, atom is like alphabet, right? When you put different alphabets together, you get a molecule or a word, right? So how many alphabets do we have? We have 26. So all these different 26 alphabet, they will give you a different word. And then how many atoms do we have then? How many atoms do we have? We have around 120, 118. Okay, 120, 118, whatever. Okay, around there, 100 something. So these are all the atoms we have found so far. There might be another new one, who knows, next time. All right, so these are the ones we have found so far. So do you need to memorize this? This is the same as the Form 1. You don't memorize this. You just need to know where is your metal. Okay, where is your non-metal? And there's one here, don't forget. Hydrate, see that? Okay, and then the middle one, the red one, is what we call semi-metal. They are half metal. This 1, 2, 2, 2. Okay, remember 1, 2, 2, 2. These are your semi-metal. They are half like metal, half like non-metal. Okay, they can conduct electricity half. They are also insulator half. So they're like half. Okay. That's it lah. Really nothing much to say here. Oh yeah. Since we are in Form 4 now, right? We are learning it in a little bit more detail. I don't know whether you remember this, guys. I don't know whether you remember this. Why is there a gap here? Have you learned this in Form 1? Why can't, for the love of God, these scientists, why can't they just arrange it nicely, block by block? Why do they need to leave such a weird gap over here? What does it need to leave it in such a gap? Okay, let me introduce one more thing. The X, okay, when you talk about elements, right, you have X axis and the Y axis. Same as coordinate. The X axis is what we call group. Kumpulan. Okay, group. And then the Y axis is what we call period. Okay, you have to memorize this, very important. So the X is your group, Y is your period. It's just like your coordinate lah. You have X coordinate and Y coordinate, right? So when we say where an element is, when someone asks you where's aluminium, how do you say it? Aluminium is here, right? So aluminium is group 13 and it is period 3. Can you see? It's like coordinate, guys. It's like coordinate. Where is point X? 5, 3. That means 5X and 3Y. Right? You learn this, right? So this is your, how do you see your group and period? All right, so which brings me back here. Which brings me back to here. Why is there such a weird gap over here? Why can't they just arrange it nicely? There's a reason behind this. Not because they are too free, they just like this shape, they randomly just choose this shape. No. They arrange your periodic table this way because they arrange in such a way that everyone in the same group has the same characteristics. Okay, let me repeat again. Everyone in the same group have the same characteristics. They behave the same way and everything is the same. Okay, they behave everything. So everything is the same. So you see, this is the useful thing about periodic table. Let's just say group 1. Let's look at group 1. You see hydrogen, lithium, sodium, okay? Na is sodium, by the way. K is potassium, rubidium, cesium, francium. You might say, sir, I only know potassium. Okay, I know potassium. Why? Because of this. Okay, potassium is batshit crazy. When they touch water, they explode. Okay, the moment they touch water, they will explode. Potassium is freaking crazy. Okay, even getting contact with air, they will oxidize and explode. Whatever shit, they also explode. So this is why potassium is crazy. So you might say, sir, I know potassium, but I don't know these. Right? You can be rest assured that if they are in the same group, they behave the same way. So you throw potassium like just now, you throw potassium in water, they explode, right? Same thing. You throw sodium in water, they explode. You throw lithium in water, they also explode. You throw hydrogen, explode as well. Rubidium, cesium, francium also explode. They all will explode in water. Rest assured. So you see why they arrange them in such a way so that it's easier for us to use. You might not know everyone, but you just need to know one guy. They are mostly like that. Okay, so they don't just purposely leave a gap here just because it looks nice or whatever. No. Like for example, right? We look at group 17. Group 17. These are what we call halogens. I don't need to know this, but just let you know. Okay, so group 17, right? You might say fluorine, chlorine, bromine, iodine, astatine, and I don't know what the hell is this. Okay, you might say, then sir, I don't know any one of it. Okay, you know chlorine, right? You know chlorine, right? Where do we use chlorine? Where do we use chlorine? We use chlorine in our bleach. Yes, and to clean the pool, yes. All right, when you go to swimming pool, that smelly smell, that's your chlorine. All right, so you can be rest. Okay, so why put chlorine in the pool? That is to clean the pool. That is to disinfect the pool. You have so many people in the same pool. If you don't put chlorine, your water is gonna smell funny. Okay, not to mention people pee inside pools. Okay, people do, right? So if you don't put chlorine, your pool is gonna smell terrible. So what's the function of all these then? Since chlorine can kill microorganisms, right? Chlorine can kill germs, right? Same thing. Fluorine, bromine, iodine, etc. They all can be used to kill germs. You know what is iodine, guys? Iodine is your yellow medicine. You know when you fall down, there's a wound, they will put yellow medicine on your wound. That's the iodine lah. Same thing. They behave the same way as your chlorine, which is to kill bacteria so that your wound doesn't get infected. You see? Same. Same. Which brings me to this. Okay, guys. This is what you need to know. Okay, this is what you need to know. These are what we call inert gases. Guys, the last group or group 18, they are called inert gases. What does it mean by inert again? Inert means unreactive. Oops, let me change the color. Unreactive. That means these gases they are very boring. They are very boring. It's like when you tell your joke to a very unreactive crowd. You tell your joke to an inert crowd. You say whatever joke, they also look at you. And then there's the cricket noise. Crick, 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 no laugh. Maybe you're terrible at telling jokes, but the crowd is not fun. Okay, so these gas, they are not fun as well. Helium, neon, argon, krypton, xenon. I'm sure you know what is helium. We use helium in air balloon. You know the floaty balloon, we put helium. Why helium? Because that's the safest gas you can use. Helium will not explode, will not catch fire, will not do anything. Helium is the most boring gas ever. They just sit down and chill. Would they explode? No. Would they give you colorful flames? No. Would they react with water and explode? No. They won't do anything. So these gases, they are very boring gases. Okay, there's no experiments about them because there's nothing to see. Okay, so this is how we call inert gases. All right, so these are your groups. Oh yeah, one more thing. These middle groups are what we call transition elements or transition metals. Okay, transition metals. You know what is transition, guys? Transition means peralihan. In this case, we call it logam peralihan or unsur peralihan, because imagine this is standard 6, this is form 1. So the middle is peralihan. Okay, can understand? So these, or I would say this is our periodic table. All right, so I don't know all the elements, guys. I don't know all the elements. If you ask me, sir, what is osmium? I would say I don't know. Okay, I don't know. What is rongium? I think it's pronounced that way. Ronginium. I don't know. Okay, beats me. I don't know. Why not you find it out and tell me? Because I don't know. All right. So anyway, you just need to know the trend, guys. You just need to know the trend. How do they behave in any way? That's all you need to know. So moving from left to right across a period, gradual change in chemical and physical properties. Like for example, from left to right, what happens? Decrease in metallic property. They are becoming less and less metal, right? They go from metal to being half metal to being non-metal. They are gradually become less metal. Change in the properties of oxide from basic to acidic. This one you don't need to know. This is chemistry. Decrease in electrical conductivity. They are becoming less and less able to conduct electricity, right? Because this is the same as up there. Right? They are slowly changing from metal to non-metal, right? Metal to non-metal, right? That means they're changing slowly from conductor to insulator. They are becoming worse at conducting electricity. Okay, and then there's one more thing I think I forgot here. Elements are arranged from left to right, top to bottom. You read your periodic table like how you read your book, from left to right, from top to bottom, and then they increase their proton number. What is proton number again? That's the number of proton lah. I'll talk more about this next week. Okay, so this is proton number 1, proton number 2, proton number 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, blah, 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 blah. That's how they are arranged. So please highlight this. Increasing proton number. This is very important. Why? Because in exam they will ask you, how is the periodic table arranged? They are arranged in increasing proton number. Okay, they are arranged in increasing proton number. So as I said just now, same group have the same chemical properties. Same group, same properties. Okay, now that's all. Okay, that's all I'm going to say. So what are you? Let me sum it up. What should you know here? You should know where the metal is, where the non-metals are, and where's the semi-metal. Okay, x-axis is called group, y-axis is called period. They are arranged according to increasing proton number. The middle is called transition metal. The last group is called inert gas. Now, that's all the info you need to know. Okay, that's all the info you need to know. Right? So, any one of you have any question? I know this is a lot of info for you to absorb in. Right? But the fact that you learn this in Form 1, so I just kind of, go a bit faster because this doesn't look, new to you. Okay, I hope. Anyway, so guys, let's go into our exercise, shall we? Let's go into our exercise. Let me run to the toilet real quick. I'll be back. Okay, guys, I'm back. Let's begin with our exercise. So see if we can do this, fast today, then maybe we can get off early. So number one, let's look at number one. Give 3 types of particles that make up a substance. So what is in a substance? You have your atom, okay, being the simplest. You have your molecule, and you have the charged one, which is called ion. Okay, guys, have you heard of this word before? Some home appliances are like Sharp, like Panasonic, they are marketing this thing lah. Okay, my aircon has what plasma cluster ion. You heard of it Okay, according to them okay, plasma cluster. Hey, I spell it wrongly. Okay, plasma cluster ion shit like that. There, that's ion lah, because some brands like Sharp and Panasonic, right? They have this ion technology that is supposed to kill bacteria in the air. Okay, does it work? Yes, it does. Okay, that's why they are selling it at quite a high price. So you buy Panasonic, you will know. Okay, so let's look at what are these. So next, the first one, you have two together, right? You have two together, right? Two and above, we call it a molecule. Okay, a molecule. And then the next one, you have plus minus, this is definitely ion, because it's charged, right? And then when you see single one, the alone one, we call it atom. In fact, this is an inert gas. Okay, because for metal, they look like this. Metal, they look like this. So when something is made from atom, like I said, it's either they are metal or they are inert gas. Okay, but mostly metal lah. So next, let's look at the next one. The diagram below shows atomic and molecular structure. So this is atomic substance. Okay, only made from atom. This is molecular substance, which means they have more than one type of atom. So what is the meaning of atomic substance? So it is a substance, substances made up of only one type of atoms. Okay, if there's only one type of atom, that is an atomic substance. So what about molecular substance? It's the same thing. Molecule made up of more than one type of atom. Just now it's only one, now it's more than one. Okay, I just put dots here because it's the same thing. I don't want to write twice. You get it. So this is only one type. This is two types. So this is a molecule. Right, next. So E, state the types of substance based on the diagrams and the meaning. Then classify the substances from the given information. So since we can see this is only one type, substances made up of only atomic particles. All right, so what is only made from atom? Like I said, all metals, iron, zinc, gold. Now you're gonna put an inert gas here, can as well. Neon. Okay, neon. Right. Funny thing about inert gas, guys. About these boring gases, your inert gases, inert gas. They actually produce quite colorful lights. Okay, they actually produce quite colorful lights, which looks like this. You see, isn't it pretty? Isn't it pretty? So if you put electricity near helium, neon, argon, and krypton, they give you this very bright color light. That's why most group 18, you remember the boring ones? Okay, the boring ones. They can be used to produce light bulb. Especially if you look at Ne. You see the second one? Ne is neon. Neon is very good in producing light. I mean, we don't use it anymore. It's neon light. It's neon sign. We used to use this in the 70s, remember? In the 70s or the 60s, this is what they use. And when you go near these light, you can hear the sound, the buzzing sound. That's a neon sign. Okay, that's a neon sign. Okay, so it's cool now because we are sort of doing it as a retro thing. So if you buy these neon sign, yes, it does. It consumes a lot of electricity. Neon sign is very hot. But nowadays, if you choose to buy neon sign, let's say you want to decorate your room, you want to make your room a retro theme. Even if you buy neon, right, you cannot find neon signs anymore. They are mostly LED. So it's like those cafe light bulbs lah. When you see those cafe, they sort of go to those they kind of decorate their cafe in an industrial theme, right? So you look at those yellow light bulb, are those the light bulb that your atuk nenek use? No, we don't find this anymore because those are extinct already. Those are all LED. You go IKEA, you see that what? You see IKEA, they sell light bulbs, right? Some of the retro light bulbs are the retro theme light bulbs they're just LED. Because we all use LED. Neon light is like obsolete technology already. It makes your room hot. It consumes a lot of electricity. Not to mention it's noisy. So why use this? Why not just use LED? Right? Anyway, so these are cool, right? They're cool. So they're not so boring after all, huh? All right, so these are your atomic substance. As you can see, they're mostly metal. And then substance made of molecular particles. So non-metals, which is your oxygen, which is your water. These are non-metals. And then number 3, you see plus minus here. That is definitely your ion. So substances made up of ion particles. You have your sodium chloride. You have your iron oxide. All right, things like that. Iron oxide. Of course, you also have sodium oxide. You also have iron chloride. As long as you have one metal and one non-metal, they will become ion. Okay, next, number 2. State whether the following objects are atomic, molecules, or ionic. So the first one, copper. Copper is a metal, right? Copper is a metal, right? So it's definitely atomic. Next, water. Water is a non-metal. So it is molecular, a molecule. Next, iron. Iron is a metal, so also it is atomic. And then the last one, sodium chloride. Sodium chloride is salt. Salt is metal plus non-metal. So this is ionic. Okay, ionic substance. Okay, next B. Classify the following substance according to the type of particles they're made up of, either atom molecules or ions. So easy lah. First one, iron sheets. Iron is metal, so it's definitely atom. All right, the next one, ice cube. Ice cube is the same as water. It is also H2O, so it's a non-metal. It is a molecule. Okay, next, salt. Told you already, salt is ion. Salt is ion because it's metal plus non-metal. Sugar cube. Sugar cube is a molecule. Right? Inside sugar has no metal. Right? You don't eat metal, do you? So you don't have sugar, iron in your, metal in your sugar. Next, marble. Right, what is marble? If you still remember your Form 3, marble is what we call calcium carbonate. All right, when you see the name like this, like sodium chloride, calcium carbonate, you know the front is a metal. Guys, calcium is a metal. Carbonate is a non-metal. So I believe you know where this is going. Okay. Metal, non-metal. So this is definitely an ion. Marbles. Next, copper wire. Copper wire is a metal. The thing inside your wire, copper. Next, lime water. Lime water is the same as calcium carbonate. So it is also an ion. Lime water. Oxygen gas, definitely non-metal. So molecule. Helium gas, although this is a gas, but helium is not a molecule. Although this is a non-metal, because this is an inert gas. Like I said, inert gas is an atom. This is a special case. Because we mentioned it in our notes, all atoms are metals and inert gases. Inert gases. Okay, fine, whatever. All right, so next, moving on. C, state an example of substance that is made of iron in the form of ions. So iron in the form of ion. So pure iron is pure metal, right? But they don't want iron atom. They want iron ion. That would be your iron oxide. Because you have iron ion marrying oxygen ion, so it becomes your rust. So like I said, iron is positive, oxide is negative. The front is positive, the metal is usually positive. Right? So guys, if you have any question, please feel free to ask. Okay, next, take for the correct statement about ionic substance. So ionic substances are formed when metal combines with non-metal. Yes, correct. So number 2, ionic substance has low melting point and boiling point. No. Okay, can you melt salt easily? No. Salt will melt at 800 something, 900 something degrees. So really high. So number 3, positive ions and negative ions in ionic substances are joined together by strong electrostatic force. Yes, it is. Positive and negative, they will attract, right? So that's what we call electrostatic force. Okay, so next, let's finish this the periodic table one. I'll go into that next week. Okay, I'll go into that next week because my other classes, they are a bit slower, so I have to match the speed. So anyway, this iron hammer definitely is atomic. I'm just gonna write A here. Rust is ionic. Okay, food is molecule. Right, next, hydrogen. Hydrogen as a gas, this is molecule because it has 2. Water is also molecule. Lemon juice is ionic. Okay, ionic because all acid and alkali, they are ions. Although they are not metals, they are still ion. I'm not going to go into that because it's not your syllabus already. So C, water is molecule as well. Rust, ionic. Oxygen in your tank, also molecule. Okay, so guys, you know what? I think I'm going to stop here, although we still have time, because this one I'll go into the next week. We need to wait for other classes, okay? Because my other classes, they are, a bit slow. So I'll leave this for next week, So guys, I hope you learned something new today, although it's a very simple lesson because half of it you have learned it in your Form 1 already, okay? Although you kind of forgot them already, which you shouldn't be, okay? So guys, have a happy Wednesday. I will see you next week. All right, so take care. See you and bye-bye.